Homeowner, how do I know these doors are the same size? The carpenter, they're alternate exterior doors. Get it? Alternate exterior. Anyways, so we're going to be looking at parallel lines and the type of angle relationships we had before. So the alternate exterior, alternate interior, corresponding same side interior and same side exterior. You're going to find that there are basically two types of relationships for all of these angle pairs when the lines are parallel. So if we look at the triangle tessellation, and hopefully we had time to do this in class, I took a triangle and I color-coded the three angles on the triangle. Then I rotated it 180 degrees and slid it over, and you can see it's over here. So the purple that was on the A is still on the over here in this corner. So you can keep doing this forever and ever and add all these pretty patterns. But the main thing that I did here is that I created a parallel line, two parallel lines going along the triangles. And then we have a transversal. So I'm really looking at just a couple of angles in this complicated drawing. One set are the these two angles right here. So you have this obtuse. Maybe I'll just call them the obtuse angles. And you can see that all of the obtuse angles created by these parallel lines are congruent. And the same is true for all of the acute angles created by the parallel lines and the transversal. So what we're going to find out is that certain pairs of angles are either going to be congruent or they will make 180 degrees when we put them together. Now here's a little doodad I created on Geogebra, which is a free software you can download. And you can do some really cool things. I constrained two lines, line AE and line FD, so that they have to be parallel, or AB and CD if you prefer. So no matter when I move one of the points, the other line adjusts so it stays parallel. All right. Now I can make the lines closer to each other or further away or play with the angles. Now, one thing you'll notice is as I adjust it and play with it, the two green angles, which in this case are acute, are always matching. They are congruent. The two green angles, since they are on the interior of the parallel lines, they are alternate interior angles. So alternate interior angles are always congruent. By the way, if you go ahead and use the vertical angles to fill in these other angles here on the outside, you would also find that alternate exterior angles are always congruent. And then if you slid from here to here, you would see that corresponding angles are always congruent. Now there's another relationship we want to look at, which are the same side angles. So same side means I have to be on the same side of the transversal. I'm making the transversal dark here, as you can see. So if I'm on the left here and on the inside, you can see that both of these angles, when I add them together, they add up to 180 degrees. Even as I move them, they adjust accordingly. So 134.2 plus 45.8 is 180 degrees. Same thing on the other side. So same side interior angles are supplementary. If I went to same side exterior, this would be like the pinkish or reddish angle, and this would be like the green. And I would find that the same thing is true. So the angle relationship theorems, and they are theorems, basically say there are two types of relationships. They are either congruent or supplementary, and the type of angle pair you are looking at will determine which relationship to use. So for the congruent angles, which ones provide congruent angles? There's corresponding angles, the angles that you make as you slide across the transversal and stay on the same side of the transversal and the same side of the lines. Alternate interior angles are always congruent, and so are alternate exterior angles. So those three sets will always be equal, and so when we run into a pair of these angles, we will set them equal to each other and solve for the unknown. So you'll say measure of angle A equals measure of angle B. The other set of angles that falls into supplementary, that means they add up to 180 degrees, are same side interior angles and same side exterior angles. So when you deal with these types of angles, it's really the same as when we dealt with supplementary angles or linear pairs in one of the earlier sections. To solve for the unknown, you're going to add both angles and set it equal to 180. So you'll have measure of angle A plus measure of angle B is 180. So let's take a look at an example. And I know that measure of angle A is 57. So I've highlighted measure of angle A, and I'm going to take advantage of the fact that the vertical angle. So I've also highlighted angle F. So I can tell that both of those angles are 57 degrees. Well, I can see angle B is right next to angle A, and that makes a linear pair with angle A. So using that, I will find angle B, measure of angle B, plus 57 should equal 180. Subtract 57 from both sides, and I get the measure of angle B is 123. Now, I'm going to go ahead and take the 123 across, and I know that B and E are vertical angles, so they're congruent. And I'm going to highlight the corresponding angles on the other line where the transversal crosses. So angle A and C should be congruent, angle F and H should be congruent. Angle E and G should be congruent, as should angle B and D. So you can see I can just take those numbers and transpose them. In example 2, we're looking at two angles, angle EBC and angle BCH, which I've highlighted here. And they say that EBC is 6x minus 10, and BCH is 4x plus 20. Well, the types of angles that I have here, they are on the interior, and they're alternating sides of the transversal. One's above it, one's below it. Since they're alternate interior angles, that is on our list of congruent angles. And you can also tell all the acute angles, when you look at the transversal, all the acute should be congruent and all the obtuse should be congruent. So I set these two equal to each other, and then I solve for x. First of all, I have more x's on the left, so I subtract 4x from both sides. 2x minus 10 is 20. Add 10 to both sides, and I get 2x equals 30. Divide both sides by 2, and I get x equals 15. So x is 15, but I need to know the angles. So I substitute in the 15 into the equation, 6x minus 10, and I get 90 minus 10, or 80. So both of these angles are 80 degrees. Then, using vertical angles, I can go ahead and fill in the angles opposite those. So I know the other acute angles are 80. Then finally, using the fact that supplementary angles must add to 180, I set up an equation, subtract 80 from both sides, and I find out that the obtuse angle is 100 degrees. I can carry it across using vertical angles and corresponding angles. So I know all the measures on these, the two lines and the transversals. In example 3, we're looking at angle EBD and angle FCG, which I highlighted here. You should be able to see that those two angles are called same side, because they're on the same side of the transversal, exterior angles. So the same sides are always supplementary. Probably doesn't hurt that they start with the same letter to help us remember. If they're supplementary, that means they add up to 180 degrees. So I take 3x plus 5 plus 2x minus 5 and add them together and set it equal to 180. I simplify. The 5 and the 5 cancel, and the 3x plus 2x is 5x. Divide everything by 5, and I get x equals 36. Then I can just go back and substitute into the expressions for the angles, and I find out that EBD is 113 degrees. Then I can take that to the vertical angle and the corresponding angles to see that all the obtuse angles are 113. Now I can find the acute angle by substituting in the 36 in for the 2x minus 5, and I find out it is 67 degrees, which makes sense because 67 plus 113 should be 180. In our last example, this is actually a little easier than our other problems. We're just trying to find the other angles in this triangle. Now, one thing I do tell you is that there's a 90-degree angle in here. And the other thing you can see is that I've got some alternate interior angles. Now, in a problem like this where you have a triangle, you can actually have a different transversal color. So let me show you. This is the transversal for one problem. Let me highlight it here. I'm upside down. Excuse me. So this is the transversal for this problem. And here are the two parallel lines. There and there. Whoops. All right. So that's a transversal. So that's how I got the alternate interior angles. Now, I'm going to highlight the other angle that's sitting at the bottom here, the bottom of this triangle, and I'm going to call that X. And I know all three angles down here have to add to 180. Now, you might have thought, okay, well, this angle up here, I know triangles, all three angles have to add up to 180, and you're actually going to get the same equation. So I add the 90 and the 56. I get X plus 146 equals 180. Subtract 146 from both sides, and I get X is 34 degrees. So I can say both of these angles are 34 degrees. Why can I say that? Well, let me change my highlighter here. We'll go to, there we go. This is the transversal for this one, and the set of parallel lines is line M and line L. So using that transversal, you can see 34 here and the 34 down here are alternate interior angles, so they are congruent as well. Finally, for reflection, describe a situation where same-side interior angles could be congruent and supplementary at the same time. You might have done, when we did that packet and we were looking at just linear pairs and vertical angles and complementary and supplementary, there could have been an instance we dealt with that. Hope that helps.